So, before beginning, let us observe the pie chart that I have taken from an open course where the analysis of composite material in various industrial applications have been presented. Now we all know that with the development of technology as well as manufacturing industries and the development of new materials, the use of composite materials have been widely used and has been incorporated in all, I would say, in all aspects of engineering and applications. Composite materials are heavily used in transportation, construction, marine applications, uh, to make corrosion resistance equipments, in making electrical and electronic components, and whatnot. So I would say composites are heavily used nowadays, uh, in different aspects of engineering applications, and there are some cases where these materials take higher load and are subjected to higher operating temperatures. So for that particular applications, we should study as a design engineer or as a research scholar. We should know what are the drawbacks and what are the conditions under which those material fail. So I would say it is very necessary and it is of extreme importance to study and analyze the failure characteristics of those materials, especially which are operating at higher operating temperature and take higher load. So let us first discuss some basics about the composite materials. In a broader sense, it can be said that composite materials are made up of two or more materials that are combined at microscopic level and are not soluble to each other. Uh, this is very important because if they are soluble, they will form an homogeneous substance which we call as an alloy. But in case of composites, that doesn't happen. Composite materials they will definitely have a distinguished phase. So in case of composites, the first phase I would say is the reinforcing phase, which is embedded into the second phase or the main phase, which we call as the matrix, and together these two phases form the composite materials. Now, in case of this reinforcing phase, the orientation of this phase can be along the axis of the matrix or can be randomly oriented. So this is one of the classification. Now, the composite materials are classified as basis of the type of reinforcement. So, in the first case, is called the fiber reinforced composites, and in the second phase is called the particle reinforced composite, and there are sub classifications as well. In case of fiber reinforced composites, long fibers are used to make the composite, and in case of small particles of very small diameter, up to nanometer level are used to make the composite materials. Now, why these materials are heavily used? Because they offer some of the distinct benefits over the conventional material that we cannot get, like strength, weight, stiffness, wear resistance, thermal conductivity. And one of the best thing about composite is that they offer flexibility. Like, I can design a new material such that I'll be able to get my desired strength, my desired weight that I want, a particular amount of thermal conductivity that I want as per my applications. So they offer a very higher flexibility, and the properties can be tailored as I want. Now, these material also give us some of the challenges, like still there are very high cost of fabrication of these materials, and one of the most important thing is that the mechanical characterization is very difficult. I mean to say that because these materials are made up of from various different materials, and each different material has its separate property. To sum up, to get an overall property, a very in-depth analysis and a complex analysis is required. So this is one of the challenge that we face in case of design of composite materials. Similarly, it has been reported that the repair of composite material is not very simple, as well as these material are in some of the cases these material are sensitive towards environmental parameters like moisture and heat and temperature. So the main theme of this presentation is the creep analysis in case of composite materials. So in this slide, I'm going to discuss some of the basics about the creep failure that we know. So we know that creep is a type of failure that we get or that we observe in case of any material that is subjected to a constant loading condition over a very long period of time. This is very important because creep we cannot any material cannot fail through creep in a shorter period of time. And one of the other important thing is that the creep failure is very different from yielding, because in case of creep, the material may fail with a stress value which is much lower than its yielding stress value, but the time taken to fail through the creep is very high. But in case of yielding failure, that doesn't happen. Yielding, I would say, for any material, if I increase the load or increase the stress, the material can fail instantly. But in case of creep, that doesn't happen. So to understand creep, what is done, for example, to do an experimental study, what is done is that a sample is taken, fixed environmental conditions like temperature is maintained, and its strain, a constant amount of load is applied, and its strain is recorded over a period of time. And it has been observed that for for general classification, such type of curve is obtained where three different regions are obtained. And in the first region, the creep rate decreases with time. Initially, it increases and then decreases because authors report that there is a strain hardening in this region. In the second region, the creep rate usually remains
Can you
constant.
elaborate strain hardening?
Uh, yes, sir. With the increase in time, the material resists the deformation, uh, uh, which is being carried out through the constant load condition. So,
So
because
why
of
it is
that,
happening? Why that is happening? Strain hardening, you are saying because time is continuously lapsing in even in second stage or third stage also. But
yes, sir.
strain hardening, you are saying it is going to happen in this first stage only. So why it is so?
Sir, I have to look into that for more details.
Okay, no issue. Continue.
Okay, sir. And and in the third stage, the rate of strain increases at a very high rate, and usually the material fails. So uh, uh, here I will be discussing about what are the effects of temperature as well as stress increment on the creep and on the creep failure. So in the first diagram, creep curve has been drawn for the same stress at with the increment in temperature, and it can be said that with the increase in temperature, the time taken to fail decreases. Similarly, the similar trend has been observed in case of stress increment. So in this figure, the creep curve is drawn for the same temperature with the increment in stress, and it can be seen that with the increase in stress increment, lesser time is required to fail for the failure of material. So yes, both stress as well as the operating temperature has an effect on the creep of the materials. Now, in case of composite materials, uh, the analysis or the research is being carried out since a very long time. And in the late 19 in the late 19th century, one of the pioneer investigation done by author H. Lilholt, where he modeled the creep behavior in case of fiber.
Vivek, sorry to interrupt you.
Yes, sir.
Again, if you remember, I pointed out that first author name is not should not come during this presentation in the text side. In reference slide, you can have first name and last name both, but here it should be only surname, okay, or last name.
Okay.
If multiple authors are there, it may be like Sahu and Saxena, or Saxena and Sahu, or Saxena and Kundalwar, or if more than two are there, then you can say Saxena et al. Okay,
Okay, sir.
ETL dot, that is Saxena and others. All right.
Okay,
And
sir.
in general, either we use this number, which reference number we are using, or we use year. Okay,
Okay, we
either
should
of
not use
them.
both.
Yeah, we should not use both because this is one of the format we can use either number. Okay, so the person can go and see the reference and the year and other detail they can see over there. Or if we are not using that number, then year, because sometimes there may be some paper in the subsequent year. So year will be indicating that okay, you are referring to which particular paper. All right.
Right, sir. But
Okay.
this time I have done wrong. I think.
No, no, no problem. That's why this course is all about that. You need to learn that how to do your presentation, what should be the font size and other things, and what should be the these reference style and others. Okay.
Sir, I'll keep that in mind, sir.
Yeah, sure.
Okay. So in this study, what the author did was he did an experimental study which was followed by his analytical work, and the author investigated different composite materials for different range of temperature and studied its creep behavior or the creep rate. So one of the remarkable finding was that both matrix as well as the fiber can undergo creep failure. Similarly, his work was followed by some other authors, and for example, like this author in 1993 did the extended the same investigation to the thermoplastic composites, where his study was based on some experiments as well as analytical study, and he found out that the discontinuous fibers are more resistant toward creep failure. So in some cases, if you use discontinuous fiber, so that is more beneficial. Now several other authors have also done similar kind of investigation. Some did in case of metal matrix composite. Some studied some presented metal matrix composite in a review article where they compared various models as well as the experimental data given by different authors. Now still till today there are various investigation still going on with the use of today's computational power, like in one of the investigation done by P Kumar and other in 2017, where they did a multi-level modeling of creep in those cases where the system is subjected to higher pressure applications, and the whole study was based on finite element method. And they found that they studied the orthotropic as well as the isotropic behavior of materials that are formed that are formed to make composite materials. So based on the literature review that I have done, I found that most of the studies are experimental studies. Analytical studies are little less than experimental studies, and now numerical studies are also being carried out in this area. So the scope and objective of this study that I have done is to extend the investigation done by actually Lord, where the author did his modeled and did experiments on nickel and tungsten fiber for different range of temperature. So what I did in this study is that the author considered the composite for a finite amount for a fixed value of a volume fraction ratio, but I extended that study for different volume fractions of the same composite. Now the author proposed that uh, the in case of composites the creep law can be understood as can be considered to be same as in case of metals. Like in case of metals, the author said that the creep can be the general creep curve can be given by this equation, where on simplification of this equation gives equation in this form, which is given by equation 2. And he said that there are some of the constant terms in this equation that remains constant at a particular temperature, and at that particular temperature this value gives the creep rate, and at that particular temperature that creep rate can be studied with the variation of applied stress. So the author simplified this equation and gave the equation which I have shown in this equation 4. And this was for the general this was for general material. And for composites, the author suggested that the equation can be extended to composites in a similar fashion. And based on the experimental study, he coined some of the uh, experimental parameters to model this equation. Now, in one of the coined term by the author, he incorporated the effect of L by D ratio, L by D D by L ratio, where D is the diameter of the fiber and L is the length of the fiber, and VF, which is the volume fraction of the fiber. Now the author considered this D by L by D to be 60 and VF to be 0.40. But in my case, what I did was I varied this VEF, and since I wanted to know what is the effect of the change in volume fraction on this creep behavior, so I changed this VF from point 2 to point 0.8. I varied this VF, and in this graph, in this figure, I have shown the findings from the author, where the experiment where the author found the experiment equation based on the experimental data points through curve fitting method, and coined and proposed this equation for nickel and tungsten composite at 800 degrees Celsius for a fixed value of L by D and a fixed value of zero point 0.4. Now, in my case, I followed this model, and I varied the volume fraction and obtained various value of log epsilon with respect to the same applied stress, and obtained the same curve which was given by the author, just to find out what is the effect of change in volume fraction. And once I obtained the curve, I found that yes, volume fraction does affect the creep behavior. And in case of the lowest volume fraction, the slope is highest, and in case of the highest volume fraction, which is pointed, the slope is lowest. I mean to say that the slope changes as we change the volume fraction for the model. So I concluded that yes, there is a change in yes, I mean the volume fraction clearly affected the creep rate. The increase in the increase in volume fraction decreases the slope of the line of the curve. In this manner, the highest slope was observed for the lowest volume fraction, and since I did the variation of only VF, I believe that the similar study can be extended to incorporate the change of L by D ratio, like the dimensions of the fiber as well. And similarly, this investigation can also be extended to study the behavior of creeping fiber as well. Because in my case, I considered the matrix will creep and fiber will not creep. So these are the references that I have used to prepare this presentation.